All right, everyone. It's time for us to get started. Welcome and thanks for attending the webinar today. We've got a great one, Beyond ProcessBook and PyVision, exploring today's industrial analytics alternatives. A couple slides for housekeeping here. We have a question and answer here at the end, so if you've got questions while we're going through the presentation here today, please put them in the chat and we will get to them during the Q&A session at the end. We will also be recording today's webinar, so you should receive an email with the recording within a day or two of today's webinar. I'd like to begin now by introducing today's presenters. Kevin and Adam, I'll turn it over to you to introduce yourself and take it away.
Thank you, JP. So my name is Kevin Jones. I'll be leading the first part of today's presentation. I'm the Director of Sales and Marketing here at DataPark. I spent last 20 plus years helping companies with industrial analytics, and certainly excited to talk today about some of the options and some of the market, and joined today by Adam Cooper, who'll be more on the technical side. Adam, say a few words.
Yeah, so I've been on kind of both sides of projects like this, helping to implement them as well as to scope them out. I have a good amount of experience in my tenure at Capstone, so excited to share a bit about migrations and how they work.
All right, so from an agenda standpoint, we're dividing this presentation really into two parts. The first part, really for anyone out there who's interested in industrial analytics, provide a background on the space, on the market, kind of why you want to do industrial analytics, and the kind of way to kind of frame the marketplace as you're evaluating and looking at different vendors in the industrial analytics space. The second part is really for those who are investigating alternatives to Pi. We have conversations quite regularly with a lot of customers in the market, and it kind of triggered the idea for this webinar is these discussions we've been having. And so we'll be looking at the role of ProcessBook and PyVision versus some of the other alternatives in the marketplace that we've touched upon in part one. Kind of one way to look at the evaluation criteria and the considerations you should have as you're evaluating these alternatives. Talk about DataPark's approach to industrial analytics and kind of where our background is and how what we see is important. And then kind of one way to do migration and a strategy to have around it. Then we'll jump into some Q&A and make sure we get your questions answered. So as I mentioned, this webinar was really triggered by the end of life of ProcessBook and the discussions we've been having with customers around the globe related to that. As you can see, we're less than a little bit over a year from the end of support, but ProcessBook has been in the market for nearly 30 years. So over that time, it's become a very popular application with thousands, if not tens of thousands of users, and tens of thousands, if not hundreds of thousands of displays. And so these customers are asking, well, what is my alternative? And so that's why we're here to talk about today. And kind of the three customer scenarios that we see out there, just wanted to frame those up a little bit before we got started. Is first, we're still seeing ProcessBook users who are deciding on the alternative. We're also seeing kind of the next step of that is customers who have switched from ProcessBook to PyVision, which is kind of the natural migration path, and are back to looking at alternatives, didn't really solve their needs and address some of the solutions they had with ProcessBook, and so back to looking at alternatives. And the third is certainly having customer conversations with those who are looking at Pi for the first time, so a little earlier in that digital transformation journey and looking for alternatives. So these are the three situations that we're seeing today, and certainly if you're in one of these three categories, this entire presentation is for you. A little background kind of on us before we jump into the landscape. Been doing industrial analytics, helping process industries for over 40 years. So the founders of DataPark began their journey in 1980 and then about 25 years ago, formed a company to focus on real-time visualization, data analytics, and process monitoring. So having a background in industry, a 40-year background of using digital data to drive decision making is in our DNA. Over the last 25 years as a company, driving lots of customers globally. So if you think about our integration experience with Pi, I think it's helpful to point out that DataPark was originally designed to leverage the Pi Historian. So the first product sat on top of the Pi Historian for its visualization. And so we've got decades of experience building highly optimized drivers for the Pi Historian, making sure that we can improve the query speed over 100 times in some cases for looking at long-term trend data. Adam will explain a little bit more of the how and the why we can do that a little bit later. But over that time period, at least 15 years of experience, converting the content that customers may have had as we sit on top of this Pi Historian. So, creating conversion tools for ProcessBook, Vision, as well as the data link report. So at the end of the day, it was really about, empowering people using the data that exists. So we've got lots of experience working with customers who have the Pi Historian. So let's look a little bit at the industrial analytics and starting with, the why. I think there's kind of three, main reasons, and they're quite obvious. You want to enhance your operational efficiency, you want to improve your decision making, and as a company out there, you need to stay competitive to stay ahead. But I think what's kind of behind that is organizations need to run better with fewer people. I'm sure a lot of you out there are facing a workforce who's retiring. A lot of your expertise is leaving the plant, and so how can you effectively continue to run better with fewer people? And that's where industrial analytics come into play. They really allow and empower every employee to become a better decision maker and do that faster. And that's really what we're trying to do with DataPark. And if you think of then the different layers of the organization, these are the layers that need to become better and improve at all times. So starting with the operator level, every operator needs to become your best operator. So we have to have an analytic strategy that meets their needs. The technical engineer, data scientists need to have analytics for the troubleshooting optimization needs that they provide. Maintenance has needs around asset performance management and reliability. IT, certainly they're going to be responsible for administering your industrial analytics applications. They're going to be responsible for the cybersecurity and more getting involved in the data ops side of the equation for enterprise-wide data integration and data movement. The senior management around the kind of the strategic decision making, you need to have a strategy for them. And then there's even the sixth layer we call the remote subject matter expert, who supports plants all across the globe. It kind of has one foot in each of these layers. There needs to be a strategy for them. So there's certainly a large number of personas may be taken into account as you're evaluating the different vendors out there. So understanding that, the question is, kind of what are your options? If we look at this next slide that shows hundreds of different logos that claim to be in the analytics space, whether it be Industry 4.0 or IoT or smart manufacturing, it can be very confusing and a very kind of cluttered landscape. So one way that I like to look at the industrial analytics is more in this generational view. We're starting with generation one, a group that's really around the actionable insights, kind of collecting and consolidating operational data to drive better decisions through industrial insights. And this is certainly where, as we talk about, Pi, from a migration standpoint, Gen 1 company, DataPark's a Gen 1 company. These tools were really born out of OT, and so I feel like there's been a lot of trust because of the the automation vendors that either build or acquire these companies. a long history in industry and in automation. The Gen 2 companies, were more on the advanced analytics area, really focusing on kind of a more of a specific, user and persona in the market, and trying to, rather than kind of managing data, this is more about leveraging existing data sources for these advanced analytics. Kind of one difference too at the Gen 2 stage is being more VC backed, so more startup companies with venture capital backing them versus being part of, a large automation industrial company. And lastly, we have the Gen 3 companies, the newer players out there, which are a little more, AI, ML, algorithm based, so more of an algorithm first approach. So having, less user involvement and more about using the algorithm to predict outcomes, and then provide recommended actions with those. And sometimes a little more vertically focused, a little more of a surgical approach to analytics. And then, lately been having discussions around, is it a black box approach or a white box approach, or how much, trust can be put into these algorithms. So there's certainly a lot of interesting discussions going on in this Gen 3 space. And, a lot of these came from kind of an IT experience with the algorithms, and now trying to apply that to OT versus Gen 1 and Gen 2, or, more of an OT first kind of approach. So I think what's also helpful now is to, compare these generations by capability pillar. Industrial analytics is not just one thing. There's kind of 5 areas that I like to look at when we're talking about industrial analytics. If we start at the top here, kind of at 12 o'clock, we have, what we call the descriptive or exploratory analytics. So kind of the self-service tools that are used by people throughout the organization to ask questions of the data and easily be able to answer those questions. Kind of moving clockwise here, the operations management piece is then those applications and those functions that drive the insights back down to the operator level and really get us to making better decisions at the operator level. We keep moving clockwise, that the data transformation stage, this is also kind of the data management, how we collect, store, and transform that data for various use cases. The data broker piece is more how we collect or connect and make available data to outside applications. So kind of the more of the data ops piece for connecting and moving data. And lastly, as we keep moving clockwise here, the advanced analytics piece, which is kind of that Gen 2, Gen 3 focus for AI ML. So now if we overlay the various generations, first look at Gen 1, you can see, Gen 1, it's kind of touches on all layers of the pillars, but with more of a focus on the data and operations side, getting a bit into the descriptive and exploratory analytics, but advanced analytics being a little being early on doesn't reach quite as far there. So if you get to Gen 2, you see that Gen 2 kind of saw that white space and started kind of moving into the advanced analytics layer, as well as the descriptive exploratory analytics. But again, being targeted more at advanced users, a little more focused in their approach. And then lastly, Gen 3, kind of being very laser focused at using the algorithms of the advanced analytics pillar, and then trying to connect that to the operations management pillar for the recommended action. So you have the predicted outcomes in the advanced analytics stage, and then you have the recommended actions, trying to tie that back to operations. I think still some work for the Generation 3 companies to make that connection. So it's still like an aspirational goal, but certainly that's really where they're trying to connect those 2 areas. So now if we kind of look at what are the alternatives and considerations, that kind of wraps up the first part of our presentation. And now we're getting into as you're looking at alternatives, where do you go? And the first question is which generation should you consider? As you can see, it can be tempting to think, well, Gen 1, ProcessBook vision kind of firmly in that generation. Do I need to keep a Gen 1 application, or do I need to just move to Gen 2 and Gen 3? But you can see there is certainly some white space that Gen 1 provides really well. And from our view, that it's a complementary discussion, that you need to have an industrial analytics strategy that has the foundation of a Gen 1, but then leverages Gen 2 or Gen 3 for specific use cases. So it's really, these are complementary generations, not an either or. And so the key is making sure that you have a real solid foundation with the Gen 1 that complements your future strategies using these Gen 2 and Gen 3. Some of the additional considerations you need to look at are who you're targeting, because not every vendor targets the entire stack of people you have in your organization. So when you bring in a new system, a new vendor, is it seamless across the organization? Are you delivering a single version of the truth, or do you end up with different applications at different layers? As we saw, some of the the Gen 2, Gen 3 may only target a couple of these layers. So how does it all fit together? Another consideration, especially if you're in the Pi Vision ProcessBook migration discussion, is how does it integrate with your existing data infrastructure? You've got historians. Can you provide easy, quick, native integration to those historians? If you have existing content, whether it be ProcessBook, Vision, some calculations, can you reuse that content and sort of leverage the investments you've already made, or do you have to rebuild those applications? Can you migrate? What you have today is obviously the ideal situation, and that comes into how much experience does the vendor you're looking at have with the migration. Certainly, having been doing this for 15 years, I can say that it's really difficult to make a very easy migration. We've continued to refine the applications and solutions that we have to make that really easy, because that gets us into the training part. How easy is the effort to train, as we're getting applications that are used by many different people. Training becomes critical, so we want to make sure that part's as easy as possible. And then the last consideration is, of course, cost and pricing. It has to be part of the equation. And I think what's most important to look at is the pricing model, especially for vendors that have a per user pricing model. Because if you look at all the different layers of the organization, and if the goal is to make every operator your best operator, make every engineer your best process engineer, and have one application that can solve the needs of everybody, so you have one version of the truth, it can be a lot of people. And it's important to have a long-term view here of what it would look like if you did plant-wide adoption as well as enterprise-wide adoption. So those are the considerations that are really important from a pricing standpoint. It's kind of one last slide that I'll show before I hand it over to Adam. It's just the data park application approach. So we kind of look at those same 5 pillars and have a product strategy around those. So starting at the data layer, which is kind of that data management piece, how we can access that data. So we have data management applications, but typically it's more of this next layer, where how we connect to existing data sources, how we contextualize those data sources, and then transform those data sources into information that is more pertinent to your organization. Because once it's been kind of contextualized, transformed, and connected, now we get into this self-serve data analysis area, which is really that descriptive and exploratory analysis pillar that we talked about. So providing easy to use tools that all the users across your organization can use to ask questions and then answer those questions. And then we have kind of that operational layer, which is making sure we take those insights, those discoveries, and drive those back down to the plant floor for effective decision making. So it's not going to do us any good if we solve a problem, but then keep having that same problem time and time again. We want to make sure that we can operationalize the discovery piece of a root cause analysis and prevent that from happening in the future. And lastly is kind of this connection to external analytical applications. So this would be that data broker, data hub pillar, making sure that you've already connected, contextualized, and transformed data at this low level. Well, now how can we easily connect that information that you've already contextualized in a way that makes sense for your organization and put that into a third-party analytics and machine learning use case. And for us, this has to be a two-way street because we need to make it easy to get the data up and also make it easy to get the results from these algorithms back down for this operationalized use case. So the idea that you're operationalizing the results from these algorithms and combining that with the data that's coming from your more your OT layer already, and so you're seeing the results all in one place. So there's just a little background on Data Park and that intro to the industry. At this point, I'm going to hand it over to my colleague Adam, and he's going to talk a little bit about kind of how Data Park could do migrations and how that would fit into your long-term strategy. Adam?
Wonderful. Thank you, Kevin. So yeah, we're going to talk a little bit about Data Park and how migration can work inside of our platform. So first things first is we want to get connected to the data. There's two main ways to connect with Data Park. There's the standard Pi SDK or the Pi AF SDK. By providing a few pieces of information like the server address and the port number, we're able to connect and start pulling that data into Data Park to be able to utilize it and further take steps with that. So once we have that data inside of our system, there's kind of two main ways that we can use it in order to allow you to do analytics and kind of move forward with the data. So the first is for any kind of short-term requests, we would use the raw data coming from the Pi historian or the underlying historian. However, for longer-term requests, we've found that in order to optimize that process, we have an aggregate archive. So we have our PDE engine that's able to, over time, calculate these trend optimized values. And so when you're looking at a month or 3 months or a year's worth of data, it's able to keep the same shape, peaks and valleys, and overall statistics. However, it's not pulling back every single raw point. Your monitor only has so many pixels, and we want to make sure that we keep things speedy. Once you're looking at your long-term data and you do see something that you want to dive into further, our program is able to switch very cleanly between the short-term and the long-term without you, the user, really noticing, so that we can speed up your ability to analyze and dive into and troubleshoot any issue that might pop up. Next, we're able to leverage the Pi Asset Framework. We're able to pull that in directly into ParkView and be able to see that inside of Tag Browser. Any elements, attributes that you've already created, no need to duplicate or replicate those within our system. We're able to pull those in directly, and you can utilize them as tags just like you would something coming straight from the historian. So let's take a look at converting a single graphic display file. So what we're going to do is we're going to point to a graphic that has come from the Pi system. We'll get a little preview here in our window of what it looked like with Pi. And then we'll go ahead and click the convert button. That's going to run through a little bit of code. And what you'll see here is what it will look like inside of ParkView. So we can see that that process is pretty quick. We're able to then save that as a ParkView display file, and then that's available in ParkView for you to be able to use going forward. So it's a pretty quick process to convert a single graphic. So a little bit more about the display conversion. You have two basic options when you're trying to convert ProcessBook displays. You can recreate them, which tends to be kind of a time painstaking energy, or you can convert them with our converter tools. To use our converter tools, you'll need to kind of resave things out of ProcessBook. You can do this in bulk, which is typically what you do at the beginning, and kind of bulk save everything that you already created. Or you can do it one at a time. Maybe something was missed or something was created after the initial bulk. save. Once you have that in our new format, we're able to run it through our converter and then save it as either a graphic like you just saw, or if it's simply just trends, we can save it as a trend display. Our graphic conversion is a direct conversion from ProcessBook. It's able to take embedded objects like trends, flow diagrams, calculations, and then show those within the graphic itself. And at the bottom, you'll see an example of one that we've done in a recent conversion. So next, we wanted to run through the different content types we typically look at when doing a migration conversion. So like we've already talked about, ProcessBook displays. We also have the capability of converting vision displays if you've begun along that path and you're looking to migrate to DataPark. We have our own Excel add-in, so we have a tool to convert any report you've built using Pi's data link into the DataPark Excel add-in. And then it's able to do calculations and all of that inside of our own Excel reports. The various calculations in Pi we're able to convert, so the ACE scripts, the performance equations, and the totalizers. We have different tools for converting those over, and then typically there's a review process to make sure that everything looks exactly as you want it. And then lastly, we have kind of two items here for writing things back to Pi. If Pi is your historian, you often want it to be your historian of record, but if you're using our tool for things like manual entry or recording alarm events, you may want that information to flow back to Pi. And so we have different applications for being able to do Pi writebacks to get that manual data back to Pi, and also tools for taking notifications and alarm events and being able to write those to Pi as well. So a little bit more about our history with conversions. As Kevin mentioned, we've been for 15 years developing tools for converting and migrating from Pi. We continue to actively develop, refine our tools, create new tools as new things emerge. So we continue to make that part of our development process as well as upgrading our own product. We've completed conversions for over 100 companies over these years. So we have a long-standing history. We know the challenges, we know the process, and we definitely have worked our way through. Here's an example of one we're currently working on. So it's a large process industry, has about 8 sites, 250 tags total. And for them, we're doing ProcessBook displays conversions, their Excel reports, they have PEs and totalizers, and then finally, we're also doing Pi notifications and writeback. So not only do we have a history of doing this, but we're actively working on a couple right now. So next, I want to show you what it looks like if you're doing a batch or multiple graphic conversions at the same time. So you'll notice that there's no files in ParkView right now. We'll go ahead and switch to our graphics program into our converter. And what we'll do is we'll click the batch button, which will allow us to give it a folder. So the folder will be full of graphics we want to convert, and then we'll tell it where we want to output those. So it'll automatically save them for us. Then we choose which of the files. In our case, we're going to choose all of them, and then we'll go ahead and run the converter. The converter will then run through each of these one by one. You'll see a little progress bar at the bottom. Once it's able to go through all of them and convert them, then we'll get a little pop-up message that will let us know that the process is complete and that we're ready to use these files inside of ParkView. So there's our pop-up. We'll go back to ParkView. You'll notice it's now populated, and we'll open up one of these files. You'll notice it populates with values, has all of the same objects, and the graphic is more or less ready to go. So the process tends to be pretty swift, and then you're able to use those graphics going forward. And then the last thing around conversion is we're able to convert trend displays. So see on the left, a display in ProcessBook that's utilizing multiple trends. We're able to take basically our converter and make a similar looking display with our own trend object, which has lots of functionality to it. And then you're able to save that and use that going forward. So now that we've talked a bit about the migration, we want to talk about the capabilities of ParkView and DataPark on the whole. So we've got a few videos that we'll take a look at. The first one here is around diagnostic analytics. So we're going to start with our steam graphic here. And basically what we've been told is that the steam flow on the number 9 boiler is having some issues with oscillation back in the past. So we start with our graphic, and then we'll go ahead and we'll double click on that value in order to pop open a trend. We're going to then kind of show some of our options for changing time spans. So we have a drop down so that we can change it to a 30-day span. Then we have some buttons to kind of arrow around to get to the time that we want now that we have the span that we want. Once we see our specific area that we want to dive into, we can highlight it to do a zoom. We can further zoom if there's kind of a specific region we want to look at. So in this case, we can see that we have the very start, as well as these kind of big swings every several minutes. We can kind of guess, looks somewhere between like 5 and 10 minutes. So to dive in a little bit further, we're going to refine our span just a little bit. We're going to make it a 3-hour span. Then we'll move it over so that we have some of the beginning and then a good chunk of the oscillations. And once we do that, we now want to compare this to some of our other tags in our graphic. So far, we only really know that there's an issue with the 9 boiler. So next, we want to see if there's an issue with a different boiler, specifically number 11 here. So we'll drag that tag and we'll add it to our trend. What we can see is it looks like it has a pretty similar pattern. By dragging the y-axis, we're able to overlay the two on top of each other and see even better that these patterns match up pretty well. So we can be pretty sure that whatever issue is happening to 9 is also happening to 11. So in that case, we're pretty sure 11 is not the source of the issue. So next, we're going to look at kind of the next layer down to try to figure out if the issue is kind of persisting in the layer beneath it. So you can see we've got a couple different objects in this next layer here, specifically PRV1 and PRV3. So we'll grab the steam flow for both of those. And curiously, we notice that our green tag flat, probably not the issue, but our purple tag for PRV3, again, seems to have that similar pattern. So we can be pretty sure that the problem might be in PRV3 or somewhere underneath it in the diagram. So we're going to go ahead and we're going to grab the steam coming off of process machine 1, and we'll add that here. And we'll do the same for process machine 7. Now, starting to get a little messy, so we're going to move our yellow and our purple, or sorry, our yellow and our green up. And we're able to use that lovely y-axis drag here. And again, we are seeing that these patterns are overlaying on top of each other, and they look like they're at the same frequency. Now, to get a better feel, so visually we can see that it seems like all 4 of them have the same kind of oscillation pattern here. So the last thing that we can do is we can turn on FFT inside of the trend here. FFT stands for fast Fourier transformation. And what this is going to do is it's going to basically analyze the oscillations or the cycle. You'll notice that all of our tags have the exact same peak. So visually it looked like they were the same, but now we've been able to use a tool in math to determine that indeed they all have that same peak there, which means that they all have oscillations with about the same period time. So knowing this, we know that our issue is most likely having something to do with PRV3, and then we can use that in order to kind of dive in or figure out solutions further. So next, let's take a look at advanced analytics. So specifically, we're going to try to dive into an issue. We've been told that the steam flow keeps going low, despite the fact that things seem to be running fine. So we'll open up a trend here. And we'll want to pay attention to the trend in the upper left. And we'll see that if we go back a little bit period of time, we see that the steam seems to be dropping, going up and down and having some issues. So we sync And we noticed that really none of the other tags seem to have peaks and valleys either. So what we thought might be a process issue might end up being a sensor issue. So in order to work around this, we're going to build a soft sensor. So first, we're going to get the data into the time span that we want, and then we'll add a few tags to it so that we have what we think are all the relevant inputs. Once we do that, it's pretty quick to build a model. We'll choose PLS. And then we'll see once the model is built up at the top, we've got a good R-squared of 0.891. And at the bottom, all of our variables have pretty similar importance. So we know that our inputs are pretty good. From here, we're able to launch a prediction trend. So this is going to give us our input, our original output, as well as our predicted output. We're going to drag in that predicted output, that's the bottom tag in the trend, so that we're able to use it in the future. So the idea is that rather than having the boiler go down or waiting until the boiler goes down, we can use our predicted value when we need to. So to make it a little easier to see, we'll turn it red here. We'll change the max so that it matches the original tag. And we'll just kind of do a little visual inspection to make sure it's looking okay. So we'll delete out those original tags so that we can get our trend back to where it was. But you can see that it doesn't have any of those dips specifically in this zoomed in range. So we feel like our red tag is pretty good. Lastly, we'll hide it. We really only need it whenever the steam goes down. And it's just a tool that we have so that we can be ready to go in case that we need it. And the last thing we'll talk about is going to be operations management. So this is an example of a center line. You can see that we have a list of tags and groups. We have a current column, so we can see how they're performing right now. We have some limits, which show us basically what we should be running at or what they'd like us to run at. And then we have columns that represent different periods of time. In this case, we're looking at different periods of days. So each of those numbers in those columns represent the average over those days. And we can see that some of them have turned to color. That lets us know that the value is outside the limits, specifically that final purity limit on Wednesday. So we want to dive in and try to figure out what possibly happened to that. So we're going to trend for that specific day. And here we get a trend not only with our purity tag, but with a few other tags that we feel represent what the purity tag might be doing or might happen to it. So we'll zoom out a little bit and we can see that for the third, that's our day in question, that it's kind of okay at the beginning, but then goes south and then finally pulls out of that. So we'll synchronize to look at our other trends to see if any of the other tags have kind of any large jumps or dips that might indicate things. And to give us an even kind of better option, we'll go ahead and we'll turn on our smart mouse and we'll drop some smart mouse pins. So these just give us a visual indicator of the exact value at the time, and then they'll hold still so that we can kind of look and compare them. So we'll drop a pin on each of these. And as we do this for basically the same time when we think things start, we'll notice that we have a big thing up there with our chemical additions, but also some things with our reactor feed makeup in the bottom right. So we can see that there's some things with the reactor feed makeup around that same time. So we'll pop open a clone of it, and then we'll drag on the reactor flow inlet. Now, inlet obviously has a bit of a time delay versus the outlet. So in order to line these up a little bit better, we'll use our time delta drag feature in order to do some time shifting. And we'll take our reactor flow, or reactor inlet flow, and we'll shift it back about 12 hours, which is our, tends to be our residence time. And lo and behold, we'll be able to see that the dips and the valleys kind of correspond to each other. So we're pretty sure that the issue has something to do with our reactor feed, either the flows or the level. So we'll zoom in on the relevant time, and then we'll go ahead and we'll launch an associated trend, which is basically the control loops for all of our tags. We'll grab the time span from our previous trend and then do a sync. And if we notice in the upper right, our tank level controller seems to have a huge spike and then quite a bit of oscillations afterwards before finally getting control at the end of the span. So we can be pretty sure that that's the issue here. Now, the last thing we want to do is we want to see if this has been an issue before or if this is a new issue. So we'll go ahead and we'll launch a Pareto chart. And we can see there that the biggest bar at the top is those makeup tank controllers. So you can see that this has been an issue in the past. And so it's not a new issue. Now that we've gone through and we've kind of figured out what happens, we'll go ahead and we'll copy in a comment here. So checking the makeup tank controllers, that's what we believe the source to be. We can save that, and then that information is available for others going forward. So last thing we want to mention here is just a case study of one of our customers that's done a conversion and migration recently. So S-Oil in Ulsan, South Korea is a fairly large facility. It has 150,000 tags with about 20 years of historical data. That ends up being over 800 ProcessBook displays, over 100 Excel data link reports, and they have over 100 users. After going through the process of comparing DataPark to other options, they decided to go with us for a couple of reasons. Some of them are our trending, so specifically the fast performance of the trending using the performance data engine that I mentioned earlier. So being able to quickly switch between sort of the aggregates or the archive and then the raw data. Advanced trend functionalities like FFT that you saw earlier, things that are able to take your trend data even further. The ability for DataPark to connect to multiple sources, whether that's an underlying historian or some other system. DataPark then becomes your one-stop shop for all your data, making it easier for your users in order to kind of do the analysis they want to. And then in terms of cost, they liked that we had an unlimited license structure for users. That and a few other factors led to an overall lower total cost of maintenance. So they were, year after year, they were spending less and in their eyes getting more. And then finally, it was a quick implementation. It took less than 1 month to do the content conversion. So all of those displays I mentioned previously took less than a month to convert those. And ultimately, they've been happy and have been running with DataPark since.
Fantastic. Thank you, Adam. Thank you, Kevin. That brings us to the question portion of the presentation. We've got a few here. If anybody out there still has more questions, feel free to put them in right now, but start with the first one here. How long does it take to convert a typical site to DataPark from ProcessBook?
Yeah, I can answer this one. So typically it takes a couple weeks. The process is the site identifies the content they want to convert, the displays, the calculations. We then run them through our different converter tools. There's a bit of a manual check just to make sure everything looks good. And then a little bit of training at the end, and yeah, they're up and running.
Great. Next question here. How effective is your conversion tool? We've done this before with other migration utilities and they haven't all worked as advertised.
Yeah, so it's an ongoing iterative process that we try to make better and better over the years. I'd say right now it's somewhere between 90 and 95% of displays will convert with no issues, and occasionally there's something that's found on manual verification that needs to be looked at. So yeah, we do a pretty good job. We find that our experience helps us make sure that these go through pretty smoothly, and certainly don't want to run into too many issues. So we do our best to add and make sure that the tool gets better and better over time.
Just to add one item there, JP, or what Adam said is, we did our first converter 15 years ago. So we've had a lot of experience in this, and over the course of that time, running into different elements, different objects, and building that into the converter so that, once we run into something new, then we will anticipate that going forward. So it's, as I mentioned in the webinar, this is really tricky to get a good converter. And I think our 15 years of experience has shown that we've got as good as it is out there. So add that little item.
Great. Okay. Let's see, next question. Hello, we currently use Pi for our historian and ProcessBook. I'm curious to learn more about the DataPark historian option. Can we use our existing Pi tags, and are there pros to convert to DataPark historian versus keeping Pi historian? So maybe that's a question for another time. I don't know if you want to take a stab at that.
Yeah, I'll just mention briefly that we're kind of able to do both. We certainly can have our tools sit on top of the Pi historian and then able to read in that data. One of the advantages of that is certainly not only can we get the Pi data, but we can possibly get other data that you might have had trouble getting into your Pi system. Or there is an option to convert things to the DataPark historian. And that's something that we can explore a little bit more on a one-on-one conversation.
Great. Thank you. Here's a new one. Are there tools to auto-generate park view graphics from Honeywell DCS graphics? Maybe that also falls outside the scope of this.
Yeah, I need to do a little bit of research. Right now, Pi is the kind of the main built-in converter tool that we have, but we are working with third-party vendors and are able to convert some other displays. So I need to check on that specific one.
Okay, we'll follow up offline on that one, but thanks for the question. Let's see. How might you migrate an entire system like ProcessBook without negatively impacting operations? How have your other customers approached this?
I'll take this one to start with, JP. So first, I just point out that, that all the conversions we do, they run 100% in parallel to the production system. So we're not impacting operations at all. It's it's really critical that plants can keep running in the way that they're used to. So there's no impact to the control or automation network, no impact to the existing historian. So all the conversions done offline, and do some training, and then figure out our go live strategy. So we really are careful about this change management topic, and making sure that we can minimize that that change management as much as possible. Adam might have an example of one we've done recently. Can you think of some of the steps that you went through on one of your recent migrations?
Yeah. So first thing, we worked with the site to identify all the content they wanted to migrate, make sure they got the displays, the Excel files, calculations. Then we ran those through the converter, and then we worked with the site in order to do some verifications just to make sure they felt comfortable with the converted content, that we're getting the right results, that they felt that they could trust them. So after a bit of verification and a little bit of cleanup work, we then moved on to training. So we had worked with the super user most of the time, but when they're ready to roll it out, we worked with them to help develop training so that we could get their staff used to the new tools, explain how all of their same graphics and displays were all there, they just looked a little different. And then with a little bit of training and then some questions and troubleshooting afterwards, the site was ready and was able to slowly migrate them to the new system.
All right, thank you. Let's see. We've been checking out some of these, quote, Gen 3 AI tools. How does something like DataPark compare to those?
Yeah, well, I'll take this one. It's a really good question. So the way I view it is they're complementary solutions. That it's not an either or situation. The AI ML vendors are really good at that that algorithm kind of solving the problem that you have, and using an algorithm to help solve that. Where these generation 1 tools like DataPark are really there to help you solve the problems you don't know you're going to have until you have them. 6 weeks from now, a problem could occur, and you need a set of self-service discovery analytics tools to help solve that problem quickly and effectively. So having a real kind of a strategy around each of these generations, and it's a complete stack of industrial analytics tools, and so DataPark is very complementary with all of the the vendors that I shared there, whether it be providing complementary functionality or from a data operation standpoint, providing easy access to the underlying data, both up and down. So I think it's really a complementary discussion, and it's part of a larger kind of strategy around how you're going to handle the whole stack of analytics.
Great. All right. Thanks, Kevin. I think that brings us to the end here. If we didn't get to your question, we'll get to that offline. But thank you again to Kevin and Adam, and thank you all for joining us today. And we'll see you next time.
Yeah, thanks, JP, and certainly thanks to all the attendees who joined. Had a lot of fun.